So we're going to look at Scoring Accelerator now. And as on most of the other videos, I've already connected to my Teradata system. So what I have is an enterprise miner model that brings my data in from Teradata, does a clustering on it using 5 clusters. And then I have this score and score export node. Together, these nodes write out to the file system some metadata about the scoring, as well as some code, including a data step, some DS2 code, Java, C, and PWML if you want. So what I'm going to do is actually pick up that code on the file system and publish that into the database. Now, there's several ways of doing this. If you have SAS Model Manager, it's really easy. You have a checkbox or a tick box if you're outside the US, and some run buttons, and it happens fairly seamlessly. If you are not running Model Manager, you can still publish these models, but it's a bit more of a manual process. The first thing we need to do is initialize the macro publishing subsystem. And then we have 2 ways of publishing these models, these enterprise miner models. There's the deprecated way, which was our original way, which created vendor-defined functions on the database. It worked well. However, we found a couple of maintenance issues with it. The fact that every time you published a model, you got around 5 vendor-defined functions, each of which was interrelated. So it became a bit of a maintenance nightmare. So with the release of DS2 and the code accelerator and the embedded process for Teradata, we rewrote the scoring mechanism to make use of the DS2 components. And this is now the default way of publishing, the way I'm going to show you. So the way it works is it creates a table, or we create a table in Teradata that holds the DS2 code. Internally, it's stored as a blob, binary large object. So I'm going to create that table on the database. And you can have multiple tables, maybe one table to hold all the mining projects from a particular department. Or you may have multiple tables holding all the segmentation models, and you may have another one holding all the churn models, for example. It's up to you. You can have one big table that holds all the models and have row-level security put onto it, so you can control who can access what models. So I'm creating the table. It's being created in the main data database, and it's being called test models. If the table exists, replace it. I then call the publish model macro, which picks up from the file system that information that was generated by the score export node. I put that into my test models table. I give it a name. I'm calling it clustering. If it exists, replace it, and the default is use the embedded process, so the DS2 style scoring. So I run that, and my model is now sitting inside Teradata, ready for me to score. Before I move on to the scoring, though, I'm just going to make a little bit of a detour. The reason I'm doing this detour is the data I'm going to score is coming from Hadoop. I want to show you how easy it is with Teradata Query Grid to pull data from Hadoop and score in Teradata. So one of the key components of Teradata Query Grid is this concept of a foreign server. So a foreign server is something that's defined by the DBAs, and it abstracts from the user all the details they need to get to these foreign servers. So in this case, I have a foreign server called Apex. I'm talking to a Hadoop server via Hive at this particular IP address on this particular port, using this particular username via this particular IP device, using this particular mechanism to get data out of Hadoop, and this other mechanism to put data back into Hadoop. As an analytics user, I don't care about any of this information. The DBA can set this up for me once, and then I just need to know what it's called and have access to it. So I can go in here and create myself a view, which is called cluster_hy, which is simply pulling the data from that Hadoop server. Remember it was called Apex? Here we have @Apex. So this is saying go off to my Hadoop server and get me this data. The data I want is in a schema called SAS E2EH. And the data set I want is CL_prep_out_HTTP. So now when I query this view, it will go off to the Hadoop server, which is a Teradata Hadoop appliance, sitting on the same InfiniBand as my Teradata server. It will surface the data up into spool. My DS2 code will then score that data, write the results back to a table inside Teradata, and then flush the spool so the data is no longer required. One of the other key benefits is if I have, say, 10 years worth of data sitting on my Hadoop server, and I only want to score the current year, I can put a where clause on this query, on this view, and that where clause will be passed through to my Hadoop server as HiveQL. So instead of bringing back 10 years worth of data, which could be billions and billions of rows, I'm just bringing back the data I'm interested in. So let me run that. And now this is where I actually score my model. If I'm using SAS Model Manager, I click a button that says score. If I'm not, then I run a stored procedure in Teradata called SAS Score EP. I tell it the table where my models are stored. Remember I created that table called test models? That's what I'm pointing to. Which model do I actually want to score? In this case, it's my model called clustering. Where's my data coming from that I wish to score against? That's coming from my cluster HY view, which is actually under the covers coming from Hadoop. And I'm writing it to a table called clustered out. And that's my primary index, so I can link it, or primary key, so I can link it back to the original data set. So I can now run this. And under the covers, it's generating HiveQL, spinning up a Hive instance on my Hadoop server, getting the data, transferring it over the InfiniBand and Binet to my Teradata system. My Teradata system is then doing the scoring of the model and writing the scores out to the database. And then, in as much time as it's taking me to tell you that, it's completed. So, just over 20.5 seconds to bring the data from Hadoop, score, and place it inside Teradata. If I look at the raw data, again to show you there's no smoke and mirrors, that's what the raw data looks like that we've scored. And if I do a proc freak, we can get a bit more useful information out of it. And we can see cluster 1 is the largest cluster, and cluster 4 is the smallest cluster with 9.24%. So cluster 4 is probably the cluster worth investigating.
Paul, Lisa, thank you. This is fascinating technology. We hope you have found this session very informative. On behalf of SAS and Teradata, we thank you for joining us, and we look forward to bringing you many more of the SAS and Teradata technology showcase. Thank you, and have a great day.